All right. So we start programming last week. We talk about how to analyze the problem, and we talk about how the problem 1, 2nd, and the third problem are being extracted, how they are like behaving, like how we can analyze the things, right? And then we went to the particular to get to know about the alternative solutions as well, right? And yeah, did we wrote about these control structures? Yes, everyone. Did we write about the control structures as well? We didn't, right? Okay, Pehara. Okay, so I think the last place that I was talking about, it's the end of that iterations example, right? Where we talking about that roundabout thing, right? Isn't it? Yeah, I think it's over here. But people, I think we have, we didn't wrote about, but we discussed, right? Did we? As I remember how I was explaining this to you, like doing it for 40 times and all these things. Ah, yes, we haven't explained, like we haven't take the note regarding this, right? Yes. So let's take the note, people. So yeah, have the heading problem solving using algorithms. No, Tesandu, we haven't write anything yet. This is just a starting. So I'm asking you to put the heading problem solving using algorithms. So let's define what is an algorithm. So copy this down. Okay, can we move forward? Yes. Can we move forward, people? Okay, so moving forward. And write the heading control structures and copy this very first sentence as the very first sentence. Okay, moving forward. So under the same heading, Roman number 1, sequence, and you may copy what the sequence is. And regarding the example, go with the second example. Oh, what is that? All right. One is done. How about others? Anyone who is still taking these things down? Okay. So moving forward to the selection part. So it's better you copy down the selection. Later, I'll take you to the example. And meanwhile, people, can you raise hand if you are from the Nanapetha Institute? Okay, it's Yasiru, Dasit, and Sasrika, right? Okay. Right. Thank you very much, everyone. Thank you very much. Right, that's it. Thank you. Ravindu, we wrote about the sequence at the previous time, Puta, like it's better you leave, yeah, how many rules until the selection, people? Yes, how many rules we spent until the selection? Yes, can anyone confirm, please? Okay, we have like 20. Yes, okay, like 20 rules. Yes, yes. Ravindu, you better leave 20 rules and go with the selections. Ravindu, yeah, Ravindu, earlier I had the idea of having the physical class, but problem is, Puta, with the time constraint, I really don't have a time now to have the physical class, right? So earlier I was having the idea of having the class on Mondays, but with the situation, I really don't have the time to manage that, Buddha. So it's only the physical class, that it's only the online class that you have here with me. So you have to stick to that particular one. Okay, are we done here? Okay, one is done. How about others? Okay. Anyone who is still writing? All right, so let's move forward. No, Tesandu, what Ravindu was asking, whether like can I start the physical classes, but what I was explaining to that, it is not possible for the moment, like since I don't have enough time to manage that. That is what Tesandu Ravindu is asking. Okay, so regarding the example, it's better you go with this. Right, so this is the example for the selection. Okay, so one is done. How about others? All right, can we move forward? Okay, moving forward. The last one is the repetition. Or some people call this is as an iteration as well. Okay, are we done? Yes, everyone. Are you still writing? Anyone who is still writing? Okay, moving forward. For the example, you can take the first one. Let's write these things, people, as the example. Okay, one is done. How about others? Anyone who is okay, Tesandu. Okay, Tesandu, go on. Right. Moving forward, Tesandu, how about you? And Denuka, confirm me. Tesandu has said okay. Denuka, how about you? Right, great. So now we are going to learn how to represent these things in an algorithm, right? So that is why we are going to learn about these algorithm representation, or like the representation of an algorithm. Now, algorithm, there are many ways that you can introduce, or you can draw a particular algorithm, right? It is not just one particular task which you are capable of, where the problem is capable of showing itself to the users. So we are using two famous ways. One is called the flowchart. The other one is called the pseudocode. Pseudo, which means not real, right? Pseudocode. So first, let's look into the flowchart. Then we'll look into the pseudocodes, right? So have this subheading: representation of information and technology. Years gone with that, representation of an algorithm. And under this, yeah, you don't need to write the any particular explanation. You can go directly for the flowcharts, and you can say this particular sentence. Okay, are we done? All right. Let's move forward. So now you have to learn about some particular symbols. Right now, these symbols are there to represent the algorithm. Sasrika, I miss your message, but are you done? Right, great. Now, I told you we are drawing the flow chart to show some algorithm. So algorithm in the sense, it's kind of a solution that we are going to plan, or like that we are going to give, right? So how we are going to represent our algorithm, it's one way is using the flow chart. So to show the flow charts, before I go to these symbols and all these things, තෙසඳු dramatic manner කියලා කියන්නේ අපි සාමාන්‍යයෙන් කියන්නේ නාට්‍යානු ස්වරූපයෙන් කියලා කියනවනේ. dramatic කියලා අපි කියනවා නිකන් අර කතාවක් විදිහට. ඒ කියන දේ, right? So look at these are the flow charts. Right now I haven't told you how the flow chart is being drawn, right? So look at it first. So it has a start and it has an end. Here's another. Can you see that? And it has some parallelograms, has some rectangulars, have some arrows which indicate the flow. So like if you look into this, if you try to understand this, let's just give you a simple example, right? You just start it. So you input the radius of the circle, calculate the area of the circle, output the area of the circle, and end, right? So different shapes are there. Shapes indicates different meanings, right? So that is what is meant by these symbols, right? So to indicate the start or end, we use this shape, and people, this is not rounded rectangle, this is an oval shape, right? So we can take the oval shape, and to indicate the inputs and the outputs in our algorithm, you can use a parallelogram, right? Samantarashrayak kila අපි කියන්නේ. Right? Then to indicate the processors, you can use a rectangular, and for the decision making point, or where, like whenever we find a condition, we use this diamond shaped box, right? And the diamond shape has the ability of provide two outputs, right? So it can only provide two outputs, not less than that, not more than that, right? So it's always two outputs from that. And we use arrows where we place the arrowhead at the end of the line to show you the particular flow, right? So like you see in here, so it starts, then it flows to the input, the radius of circle, then it flows to the calculate the area of the circle, then it flows to the output the area of the website. So likewise, right? So you can use the arrows to indicate to which direction this algorithm is going to flow. And the connectors, it's something a little bit advanced. We use connectors to connect different kinds of approaches together, which we are not doing here. So we take the connector and we indicate this is the place where it's going to end just for the moment. And we put another connector in the other side and say, okay, this is the place where we are going to do the continuation, right? Denuka, like I said, we can use the connector symbols. Like think about a situation that you ran out of your page, right? So your algorithm is big. So one page is not sufficient. So at the end of your page, with the flow, you can put a connector, right? So like this, if you think this is the end of the page, so you can put it like this. We generally put a capital letter inside the connector. And when you move to the next page, you can put the connector and you can flow. Got it? Okay. So, right. So let's write down these things, people. Right. Let's draw the symbols and the function, like literally the table 1.1. Right. So it has different kinds of symbols. I'll scroll down little by little. Right. So you may write about these things. I'm scrolling up little by little. And let me know when you are done. All right, one is done. How about others? Okay, is there anyone still who write in these things? Okay, people are moving forward. Please indicate me if anyone is still taking these things down. Right. So moving forward, and people, I want to add some notes for the examples that we wrote. I guess it will give you a much clearer clarification. Did we write the first problem paper? Just tell me, like turn it to your places where we wrote the examples of these things. Did we wrote the first problem? No, we didn't, right? Okay, Udamya. So what were the problems that we went through, people? Just tell me the problem numbers. I remember of writing the third one, third, fourth, and seventh. Okay, great, Rosetmi. Thank you very much. Right, and in third, I think I have mentioned you what is the sequence, what is the selection, and what is the iteration, right? And yeah, Ravindu, hold on a second. Hold on a second. Right, and here what I want you to do is, I want you to circle these things up. This and this. Right, and take both things together. And there it's better you say selection condition. Right? Selection condition. Oh, I'm sorry. Selection condition. Yeah, Denuka, we wrote that section as the selection. So earlier we mentioned this third and fourth sections as selection. So I want you to underline this specifically and tell, underline or circle it, or like however, either you can highlight it and say it is a selection condition. So the selection and selection condition, that is the selection condition describes what is the reason to be selected. Right, so selection condition. And this particular purple one defines the iteration condition. I'll write it down. Okay, are we done? Let me know when you are done, people. Okay, so I'm clearing this out. Does it, we can say it as branching as well, but it's the word which is using frequently is the selection, right? Okay, I'll be clearing these things. And then let's walk. Right, so the next one we wrote is the fourth one. And of course, yeah, I have named that as the selection as I remember. That's okay. And the next one we have done is the seventh, right? Yes. In the seventh, yeah, people, in the seventh, I got two conditions. What is my condition? What are the conditions? Yeah, Udamya, here I need the selection conditions. What should be the selection conditions? If the remainder equals 0, that's going to be a selection condition. Or if the remainder equals 1, that's going to be a selection condition. Right? So highlight those or round those and say selection condition. Right here, we are going to say selection conditions. Okay, are we done? Udamya, dividing the number by 2, we can't take it as a, first thing, we can't take it as iteration condition because there is no iteration over here, right? It is just purely the selection is there. The one number is taken, it is divided by 2, and based on the remainder, we figure it out as an even number or an odd number, right? So clearly it does not have iteration. If the iteration is there, we can see some particular steps are happening again and again. So nothing is going to happen like that in here. And again, dividing number by 2 cannot be taken as a condition because dividing number by 2 is a process. That's something we have to do, not something we have to decide. Got that, Dua? Okay. Yes, Dinelka, what you are saying is correct. The input in part and the divided number by 2 and those two are the things that can be carried out as a sequence, right? Then the condition will be checking whether the number is equal, the remainder is equal to 0, and then deciding the number as even can also taken into the sequence part again. So 2 lines of sequence, 1 condition, and again 1 line of sequence. Not actually a sequence, we can't say that it is a sequence. It's actually a kind of a part of the selection, right? So I think on the other day, I mentioned these two as the sequence and these two as the selections, right? I think that's the way we have written in last week. So now we mention about the selection conditions. Right. So my next question is, now since there are 2 conditions that you can see, like we are deciding whether a particular number is odd or even by considering these 2 conditions. Like, can't we do the deciding part just taking one particular condition? Yeah, we should be. Yes, Udamya. How it should be? Any ideas? How the condition needs to be there? Yes. Anyone else? Any suggestions? Instead of these 2 conditions, can we ask can we do just one particular thing and decide whether it is even or not? Yeah, just see whether this can be done. Very good, Udamya. Very good. Very good. So what Udamya is saying, if the remainder is 0, then we can decide it as an even number, and without checking again whether the remainder is 1, if it is 0, it is an even number. If it is not, it is an odd number. Right? So we can have our decision due to one particular condition. That is the actual way that we are dealing with the programming when we are doing the programming. So we just check and we create a condition, and if it is true, we do something, and if it is not true, we do some other things. Right? So if I take this particular example, I can decide whether a number is odd or even just by having the condition, like we divide the number by 2 and we take remainder and we check whether it is equal to 0 or not. If it is equal to 0, it is an even. If not, it is an odd. Are you getting this, people? Are you getting what I'm saying? We really don't need 2 conditions to figure out. Just one is sufficient. Okay, can we ask that question? to have the same outputs in a different manner? Yes. Can the condition be written in a different manner? Yes. People think. Can we write it in a different manner? Can't we say it like this? Yes, Udamya, what I'm asking is, can we write the same condition in a different way to have the output that we want? Now, what is the output we want? We want to find whether the number is odd or even. So we have asked the question, if the remainder equals to 0 or not. And we can ask it in the other way around as well, right? Like we can ask the question, if the remainder equals to 1 or not. We can ask it like that, right? So we can go either like this way or either on this manner, right? But the according to the yes and no, the place of the outputs can be changed. Now, if the remainder is equals to 1, if it is yes, then it is an odd number. If it is not, then it is going to be the even number. In the earlier question, it's the other way around. If the remainder equals to 0, then it is an even number. If not, it is an odd number. People, are you getting this? I'm telling you a very important point. We can make the condition in several manners, actually in 4 different ways, if you think accordingly. Yes? Are you getting the concept? People? Right, great. Tell me if I need to be repeated. Ravindu, you are not getting it, right? Okay, Ravindu, let me draw it to you and show, because it's that important for you to understand. Hold on. Okay, Ravindu, it's like this. Yeah. Now, Ravindu, it's like this. You can don't think about the symbols that I am drawing for the moment, right? Just try to take the picture, right? Now, you can do the second step of this, like divide number by 2 and take remainder. Yes, Tesandu. That's what I'm trying to say. Right, so hereafter, I can ask the question like this, Ravindu. I can ask, is remainder equals to 0? If this is going to be my question, if it is yes, I can say even number. If not, I can say odd number. Are you getting that? Ravindu? Yeah. So Ravindu, what I'm telling is I can ask this, I can give this condition in a different manner. I can ask the question, is remainder equals 1? Instead of saying is remainder equals 0, I can ask is remainder equal 1. Then on the yes part, it says odd number. In the no part, it says even number. Are you getting it, Ravindu? Right, great. So likewise, people, we can ask this in another way. I can ask the question, is remainder not equals to 1? If it is yes, then what should be the answer? Yes, people, if my question is like this, is remainder not equals to 1? If it is yes, what should be the yes? That is right. If it is yes, the answer is even. And if it is not, the answer is odd. Yeah. And the same way I can ask it on the other way around as well, right? Is remainder not equals to 0? Then if it is yes, it's going to be odd. If it is no, it's going to be even. Right? So now you know a particular condition can be illustrated or can be asked in 4 different ways. Right? So just remember this as a point, right? Because when we are drawing the flow chart, we need these things. Right? Okay. Right. So I hope you have mentioned the thing that I told you earlier, but I was asking you to do so is to write about this selection condition thing. I think you have mentioned it clearly. Right. So this is the only thing that you have to do. You have to highlight these parts and indicate it as the selection condition. That's all I want you to do. Okay, now we are going to match these 3 solutions, the solutions that we wrote. People, hold on a second. Otherwise, my meeting is going to end. Okay. Ravindu, මට clear නෑ පුතේ වාහන එක. Yeah. Hari. වාහන එක දැන් තේරුණා. Right, okay. Yes. If remainder is 0, it is even. If remainder is 1, it is odd. Yes. That is what they are proposing at that point. That's true. All right. Now we have drawn our symbols, no? And Ravindu was asking me to show me the table again, right? So hold on, Ravindu, I'm scrolling down. Sasrika, it depends, Sasrika, like when we, Ravindu, these are the symbols. Okay. So Sasrika is asking what happened when we input minus values. So still, if we got minus values, Sasrika, still we can say minus values are belongs to the odd or even, like -2 is an even number, -1 is an odd number, right? So odd and even does not depend on the mark or the sign, right? So it's clearly depends on whether it gives a remainder as 0 or it produces a 1 as the remainder. So now what I'm going to do is, people, the example that we wrote in very first manner, it's the third one, right? We went with third, fourth, and seventh, no? So I'm going to the third example, and I'm matching that example, the third one, into a flowchart. Oh, third one, not the third one. First, I'll go with fourth one. It's quite easy, right? Look at this. Now, the fourth problem indicates only the sequence, and it says add in 2 numbers. So if I'm there to match this or map this with a particular flow chart, what I'm going to do is I need to have my start symbol. So I put start, then I take a flow, then my inputs. It is saying 2 numbers here. So when I'm writing the inputs in my flow chart, I have to say what to be done clearly. Now here it says take two numbers as inputs. So I have to say obtain, right? Instead of obtain, I can use input, enter, those kind of words, right? Obtain 2 numbers. So that's going to be my input. So since the inputs are indicated from a parallelogram, I'm going to put that phrase inside a parallelogram, right? Then after, now in case if you got a lot of inputs, you can put the inputs inside the parallelogram like this, one after the other. It doesn't matter, right? If there are way too number of inputs, you can use the input symbols as much as possible, but don't put all the inputs inside of one parallelogram. Ekaka okkoma liyanna yanna epa godak tiyenawa nan, right? It's going to give some messy illustration, right? So then now I have input 2 numbers, or like obtain 2 numbers. Then there is a process, right? The process is adding the 2 numbers. So it's easy. And I'm saying add 2 numbers and take the total. So that is going to be my process, right? And why I have said something like take the total, that is what we are doing by performing the process, adding two numbers and finding the total, or adding two numbers and take the total. So now I have to show what to be done, or like what to be given as the output. So when I'm writing the output, so here it indicates output total. So when you are writing it, you can use the word output, or you can use the word display, or you can use the word print, right? Those kind of things to indicate the output. So then you can put it inside a parallelogram, right? So you can say print total, or you can use display total. And then my algorithm is done, so I can mark it as end. Okay, is that clear, people? How I am mapping a particular problem into a flowchart? Is that clear? Okay, right. So if you got any doubts, just let me know. So let's write about this thing, right? So now you have drawn the table of symbols. Under that, you better write it like this. Put a star or point, you can say. Draw a flow chart for example number 1, right? In your book, this is example number 2, right? In your book, this is the example number 2. The problem 3 is the example number 1, right? Is it so, people? Oh, ඔගලන්ගේ පොත්වල right. So it's better you say draw a flow chart for example number 2. Then you can draw the flow chart and show how the flow is happening. Let me know when you are done, people. Okay, one is done already. How about others? Okay. Anyone who is still writing? Okay. So I want you to draw the flow chart to the problem 5. Right? So put a star and say, draw a flow chart for problem 5 in textbook. Right? So I want you to draw a flow chart for this problem. So the heading of that is going to be draw a flow chart for problem 5 in textbook. Right? Let me write it over here. Draw a flow chart for problem 5 in textbook. Right? And I want you to try this particular program to be drawn as a flow chart. Okay, since the time is up, you can do it as a homework, people. So draw it. All right, someone has done already. So draw it slowly. And I'm going to start the next session by drawing the flow chart to the problem 5. And we are going to continue to the other flow chart by next week. Right, so get ready, people. Right, so I'm going to end the session from this point for the moment. Right, so for today. So I'll see you on next week to draw more flow charts. So get ready to have a pencil and an eraser and get ready. We are going to draw more flow charts to take the concept of drawing flow chart into our mind. Right, so thank you very much, everyone. I'll see you on next week for the very same time. Right, and be safe and stay safe, people. Right, thank you very much, everyone. Right, okay, thank you everyone.